Welcome to Lesson 9, Decisions and Random Numbers. So decisions are extremely important to programming. It allows an application to figure things out on its own. You give it intelligence. And then random numbers are just nice to play with because there are a lot of things you can do with random numbers, from video games to simulations. Let's get right to it though. Okay, so let's just go ahead and clear that. So let's create a variable called x and let's set it to 10. And now let's make a decision. So all programming languages use the word if to signify that we're going to make a decision. The next thing that comes is something called a condition, a question. What do you want me to decide on? So let's decide whether x is less than 20. And then the last part after condition, kind of let the computer know that you're done writing the condition, is to write the colon. This altogether creates the syntax of the if statement. Now I want to go back to this part here, the condition. The condition asks a question. So when you read a scenario, try to derive what is this question that you're making a decision on. So in this case, I would read this as, is x less than 20? Now the result of that question, that answer, it's something called a Boolean, a value of true or false. Again, that's a little more sophisticated than what you need to know right now. You can simply think of it as yes or no. So if the answer to the question is yes, let's do something. And all we're going to do here is we're going to print out small. So let's give it a try. So as no surprise, the word small comes out because x is 10 and 10 is less than 20. So let's go to change this to 30. Now remember, this is a question. So is x less than 20 at this point? No, right? That's not an error though. Some students think that when the condition comes out to be false or no, that it produces an error. No, it just means that the decision won't be executed. And there you go. So you won't see anything on the screen. Let's improve on this, because usually when you have an application that interacts with the user, if the user doesn't get some feedback, they might think that the program has crashed or that they did something wrong. So the if statement has an additional portion called additional component called the else, which allows us to specify what to do when the condition, the question, comes back as no, false. So let's do this. Print big. All right. So in this case, if x is less than 20, we'll print out small. Otherwise, we'll print out big. So in this case, when we run the program again, we didn't receive anything the last time. We should receive something now. Let's try that. All right, so we see the word big again. Let me prove it to you by putting the 10 back in. And we got small. You should always run your programs a couple of times to check that something you created didn't modify another section of your program. So we can see here both parts of the if statement still work. That if x is less than 20, we get the small. Otherwise, we get big. So I'm going to change this not to be a hard number, but let's ask the user for a number. Let's make this program interactive. So let's say int input enter number. And at this point, the program becomes interactive. So we're going to ask the user for a number, and then we'll make a decision as to whether to display small or big. Let's give it a try. So we're going to enter number. We'll put 1, which should give us a small. And there we go. Let's run the program again. Let's test out the other side, which is something bigger than 20. We'll say 25. And there you go. So this was a simple example of working with an integer. You could also do the same thing with floats and make a decision off of it. So let's do another example that doesn't deal with numbers. So let's ask the person for a word. And we'll do input, enter language. And the idea is that if the person enters in, let's say, Spanish, we will tell them hello in Spanish. So let's review this first part. So if word equals to, notice that there's two equal signs here. We need that in order to differentiate it from the one equal sign, which is an assignment operator. This isn't really equal. This is assigning this value to this variable. The two equal signs in conjunction with an if statement is word equal to Spanish? Now, if it is, let's display hola. If the word is not equal to Spanish, then we'll just say hello in English. All right, so let's give that a try. So we'll go back to our 7, our first decision, and we see that it's too small. Now let's write the word Spanish, and we get hola. Again, never be happy running it once. You got to test both sides of the if statement. So we'll keep testing the first one. I guess we could comment it out, but we won't. And now let's write English. It says hi. Hopefully you realize that it has nothing to do with the word English. I'm going to run this one more time. And I'm actually going to produce something that you might not think of it as being the wrong, quote unquote, the wrong answer. So word equals to Spanish with a capital S. Now notice I'm spelling it with a lowercase s. So what you can see here is that this condition, this question is going to come back as no, false, which means we'll print out hi anyway. Okay? So when you make a decision, especially when it deals with strings, we're looking for an exact match. There are things you'll learn about in the future to avoid this kind of case sensitivity in a person's answer. But again, that's beyond the scope of this lesson. All right, the last example I want to do involves the other topic of this lesson, which is random numbers. So to do random numbers, we have to import a library called random. And in that library, there is a function called ranInt. And at this point, I will comment out the other lines of code, just so we can kind of focus on this last one. So we'll say number equals ranInt. Now ranInt needs two numbers, an upper bound and a lower bound. And again, one of the nice things about Replit, notice how it kind of gives you a little message kind of informing you what it wants. Ignore the word self. Self is not a parameter that you're going to have to specify in any function that we're using right now. So let's say we're going to produce a number from 1 to 10. And now let's make a decision that if number is greater than or equal to 5, we'll say print. And let's do a little string concatenation here. We'll do cool. And let's actually display the number, just to kind of prove to the person that the if statement worked. So if the number is greater than or equal to, so all these that you've seen so far, these are called comparison operators. There's 6 in total. And the link associated with this video will have you review the other ones, but I think you can kind of figure it out. There's a greater than by itself. There's a less than or equal. And there's also one that's called not equal. So all those put together give you the 6 comparison operators that you can use with numbers, and in certain cases you can use with other data types. But let's get back to our example. So if number is greater than or equal to 5, number being a random number from 1 to 10, we're going to print out cool. Otherwise, let's print out, we'll do a little string concatenation again. Nah. And let's display the number again. Whenever you work with random numbers, it's usually nice to display the number back to the user, just as proof that there's no shenanigans going on behind the scenes of the program. So let's run it. So we get na of 2. Let's run it again. Na of 3. Okay, cool. So we finally got one that was bigger than 5. So we got the word cool and 8. Now, so let's go back to our presentation. So in this lesson, we reviewed decisions, and as we saw, decisions allow a program to be smart. It gives them intelligence, allows them to make a decision on their own using various data types, various comparisons. The last part of lesson 9, we introduced the concept of random numbers and how we can use random numbers to maybe create a simulation. So hopefully you enjoyed this. Goodbye.